Hello, today I'd like to show you how to use compute.rhino3d service in Unity. So last time I showed you in the video to use Python for compute.rhino3d, but today I'm gonna use C# since Unity is based on, you can make a script on C# in Unity, and I think it'll give you a lot of like imagination. What can it be used for? Maybe it could be used for in gamings, for procedural modeling inside a game, or making a model inside the VR spaces as well. Pretty much there are many possibilities you can do with this, combining with the Unity. So I'll show you how to do this. Now go back to this the main website for the Rhino Compute service. There is a link for using how to use this in C#, which says compute for C#, getting started guide. So I'll click this and I'll show how to use this in C# environment. Now the page only shows you how to use this in Windows .Net environment, but I have experimented on Unity and it works just fine, so I'll tell you how to do this. Now, first thing you need to do is to have a library for Rhino3d IO, which is for desktop or iOS or Android, and you can download from NuGet gallery. So go to this web page and search for Rhino3d IO. Now you'll have three options: one for the desktop, either Windows or Macintosh, or for the iOS or Android. You can just download everything or just choose one that you need to have. As you can see, since Unity accepts the cross platforms like Windows, Macintosh, iOS, Android, you can use either of them for Unity as well. Today I'm just gonna choose desktop to build for the Windows. And I am going to this page. I'm gonna click this download package and download this. Now go to your download folder. You'll have this .nupkg package. Once you have this, change this nupkg extension to zip, since this is actually a zip file, and now it converts to a zip file. Then extract this file here. Now go inside the folder, and what you need is first go to this lib folder, net45, and you'll see a DLL file. Now place this into a Unity assets folder. Maybe I can make a plugins folder like this. And inside this plugins, I'm gonna copy this DLL like this. And since this is only for the standalone, I'll just click standalone here. Oops, this is exclude. I'll check out the any platform for inclusions, and I'm gonna set only the editor and the standalone here. And since they will be okay, and go back to the extracted folder, then go to the build folder and net45, and you can either choose Win32 or Win64. I'm gonna choose Win64, and copy this lib Rhino3d IO native DLL as well to this plugin folder. And For this one as well, check the editor and standalone. And for this one, check out this 686 since this is a 32-bit. Okay, apply. Now go back again. If you want to build this for the Macintosh as well, then you can also copy this librhino3d mio native.lib. Just in case, copy this into plugins. And it doesn't recognize in Windows since this is this is specific for Macintosh. It's okay. Now, another thing you need to download is a Json.Net library. Now for that one, you can download it from a asset store freely. So let's go to the asset store. Search for Json.net, and they will show you this Json.net for Unity. It is totally free to download. So let's import this, download and import this. Now I have imported Json.net library here for C# for Unity. Now I have one more thing to import, which is on this page. Scroll down a little bit and you'll see a Rhino compute.cs. Now this is the last thing you need to import. Click this and it will ask you to download this. Now after I download it, it will be on the download folder, I think, this one. So I'll copy this into, it could be on plugin, could be anywhere. I'll just put it into plugin for now. Okay, now everything is ready in order to deal with a compute.rhino3d in Rhino. In Unity. Now, as I also did in the last video for Python, you also need to get the the authentication token for compute.rhino3d. So go to this, go back to the Rhino Compute service page, then add a login to the URL. Now you'll be able to go to a page where you can get an authentication token like this. Every time you log in, you get the different code here. Now copy this, or just leave the page open for now, and go back to the scene, and let's make some script to actually use a compute.rhino3d. Now I'm gonna deal with this sample scene made defaultly when I made this new project, and I am gonna make several folders. One called scripts, one called materials. Okay, and in material I'm gonna just make a default material that I'm gonna use it to visualize the mesh that I'm gonna procedurally create on Unity using compute.rhino3d. And then on the script, I'm gonna make a new script, C# script. I'm gonna just call this test compute. Right. Okay. And I'm gonna drag this onto main camera. And let's write some scripting. Okay. Now, what I would like to do here is to make a script to use a function which only Rhino has in terms of modeling. So I want to use Rhino's modeling functions to be able to use it directly inside Unity and procedurally create a model inside a Unity window, inside a Unity scene, preferably somehow in real time. Well, as I told you last time, the compute.rhino3d is running on the server, so the speed is pretty much restricted by the speed of the server. But today I'm just gonna go with the local server that I already installed on this local Windows machine. So if you want to know how to install this in your local machine, you can look back to the last video I made using Python. I'm showing how you can install this local server, local compute.rhino3d server on your machine, on your local machine, briefly. Now let's go back to the C# and first let's import some modules or libraries. First thing I need is Unity using system.link to deal with the collections, using Rhino compute and using Rhino. Okay, and let's make a public variable. First, a string called auth token, and I should have copied this here. Okay, and public material mat to use it for visualizing the mesh. And I'm also gonna make a private Rhino file io.file3dm called model. So this instance will be used in order to save the 3dm file for the Rhino. Okay, now let's get started. We'd like to make it interactive stuff, so I'm gonna make a void on GUI and create some sliders in order to control the geometry. Now, first I'm gonna make the label the first one I would like to make is a height. Just gonna copy this. Oops, not copying it. Copy this and paste this 4 times. And implement this value for the Y position by 20. And rename this second one to be radius. And third one to be angle, and fourth one to be segments. Okay, now next let's make a slider. Before that I need to make a variable here, so private height, private float height equals the initial height, something like 10, private float pipe radius to be something like 2f, private float or integer segments to be 5, and private float angle to be something like 30. Okay, so this is a initial variable in order to make the procedural model in Unity. And let's also make a float rev height lev pipe radius rev segments and rev angle. In order to use this to check whether the value has been changed or not. Okay, now go back here, and height equals to a GUI dot horizontal slider, and the position will be 100, 15, 120, and value will be height. I guess that's it. That's okay. Maybe I need a little bit more. Oh yeah, I need to set the minimum and the maximum, so I'm just gonna set 1f to 2NEF. Okay. And for the radius, pipe radius equal GUI horizontal slider U rectangle 135 120 pipe rad, and from 0.5 to 5. Okay, I'm just gonna copy this. It's a lot of typing. Okay, and I rename this to angle. Adding this by 20, and the angle could be from 0 to 90. Right, and for the segments, and since this only gives you float, I'm gonna convert it into integer. Then what was it? Segments, and from 3 to something like 8. All right, and this will be 75. Okay, now let's check this if I got the correct value, correct one. Okay, now I have those sliders running. Now let's go back to create a geometry using Rhino3d MIO plus compute.rhino3d. Now I'm gonna test out the geometry by starting from this void start, since it's more safer. Okay, now the first thing I would need to do, as I did for this Python, is to set up the authentication token. So I'm gonna set up the authentication token first. Then also, since I'm gonna use the local server, I'm gonna set up the server address as well. So web address equal HTTP 127.001.8081 slash. I think this will be fine with the semicolon here. All right, so this is the first setup that you need to do in order to use the compute.rhino3d service. Now let's go here to make a private function called something like generate geometry, and call this generate geometry inside here, inside the void start at the starter. Okay, now first thing, I'm gonna initialize this model, which is the file 3dm. So new Rhino file io dot file 3dm, which will be used to save the 3dm file. Okay, now let's make a for loop to create a bunch of points first. Okay, I'm gonna set the num to 10 and create the loop 10 times. Like this. Right. And let's first create from the points. So for the just creating the points, I can just use the Rhino3d IO library, which is a wrapper for open Nurbs. So I don't need to use the compute Rhino service for this one. So you don't need to access the server at this point. So I'm gonna just make a point and gonna set the height divided by num minus 1 times I, so that the point aligns on z-axis and arrayed 10 times. Okay, now I made this point. Let's try to check if I really got this point correctly by checking inside the Rhino3dm file. So I'm gonna add the point to this object table for the 3dm file, and like this. And now I have added 10 points onto this model. After that, I'm gonna write this to a path, the saving path for the 3dm file. So for the paths on Unity, I'm just gonna save it out just outside the assets folder. So let's make a pass here, which is application dot data path plus model 3dm, like this. Okay, and apply here. Also, if you wanna set the version for the 3dm file, like if you wanna make this available for Rhino 5 and above, then you should type 5 here. Okay, let's check this out. So when I start up this Unity scene, it will call this generate geo function, which will create 10 points on z-axis and write it on to this model 3dm file. Now let's see if this works. Now let's check the folder above the assets folder, and here I have this 3dm file generated from C# script. Cool. Now let's open this to check it out. If I really got the file, if I really got the geometry, and yes, I do. Cool. Now based on this process, I'm gonna make a little bit more complex geometry and using also a compute.rhino3d as well. Now next thing I would like to do is to make a polygon on to this point position. So in order to make some polygon which have a segments, I need to start up from circle. So I'm gonna make a circle called circle, and using Rhino geometry circle, and let's check out the okay, I can use this one. So the center and the radius. Okay, the center will be point and the radius will be point radius, which I have created as a private variable here. Right. Now after this, I'm gonna convert this circle into polygon by using Rhino geometry polyline, create circumscribe or inscribe. I'm gonna choose inscribed polygon and circle with these number of segments which I've already created. Now in order to check what kind of function that you can use with the Rhino3d MIO or compute.rhino3d, you can go to the web page and go to this API page, which is on this address, and basically the RhinoCommon has all the function, including both Rhino3d MIO and compute Rhino compute.rhino3d API for C#. And if you just want to check the Rhino3d MIO API for C#, then you go to this page. But the disadvantages of this page is that you cannot use searching for this page. So I would rather go to this RhinoCommon page and search for the function you want to use, such as the one that I just used, like create inscribed polygon or just polygon, and you'll see some function that might work for you. Like if you go to this polyline class and search for a polygon, there is a function called create circumscribed polygon or create inscribed polygon, and it shows you that it will create a polygon inside this circle that you inputted it as a parameter. Now there is also a stop polygon, which sounds cool. And next thing you could check is that if this function is included inside a Rhino3d MIO or inside a compute.rhino3d function, which is more rich, which you could only access through servers. Now what you can do is that you can check the name of the class here, then go back to this Rhino3d API document and check the polyline here and click here, and if you see that there's a create inscribed polygon, then it is available in this Rhino3d MIO library. So yes, I can use it without going to the compute Rhino3d server for this one. Okay, now Let's also convert this polygon into curve, since this is right now a polyline class. So polygon to Nurbs curve, right? And let me also rotate this curve with the z-axis with the I times mass f deg to rad times angle. So if the angle is 30, it will increment by 30. So the first, if the I is 0, it will be 0. If the I is 1, it's 30 degrees. If I is 2, it's to 60 degrees, and so on. And what's the next one is the axis. So new Rhino geometry vector 3D. Just don't confuse this vector 3D with the vector 3 in Unity. The name is pretty similar, so you might confuse, but it's the different class, so you cannot use for this one, since this is a Rhino function. And the rotation center, I'm just gonna set it to the center point, to the 0, 0, 0 position. So point 3D. Okay, like this. Now, instead of adding points to the model, let's add this curve to the model to check if I got the model correctly. Now, run this. Go to this assets folder and open this. I already have things open. Okay, I'm gonna close this first. Open this. And I don't seem to have it. Let's do this again, eh? Okay, let's check this. If I have saved this. Yes, I have saved this. Okay, let's play this again. And go back here. See if the model has been updated. And yes, it did. Okay. Now, it's a little bit boring, so I'm gonna also move this polygon like spirally, like move this polygon on spiral position, so that it'll be more interesting. And then after that, I'm gonna loft those curves together. Okay, so curve translate new Rhino geometry vector 3D, and I'm gonna use a cosine for the x, which also deg to rad times angle times I. Okay, and for the y, 0 for the z. No, for the y it's math. It's a bit confusing because the y and z is flipped with Unity and Rhino, and for this one I have to think it in Rhino way, so the z-axis is upward. So I'm gonna, and x and y on the is on the plane, 2D plane, so I have to just change the x and y here. Okay, so mass f dot deg to rad times angle times I, and 0 for the z. Okay, is that enough? Okay, hopefully it's good. Okay, I also need to set up the radius for the spiral. Let me just set it to a static value like float outer radius to 2f or something, and copy this and multiply this here, or yeah, here's fine, so that I have just multiplied to this vector. Okay, let's check it out. Play it. Oh, I think I need to close this before I open this. Okay, play this again. And let's open this again to see if it's on the spiral position, and yes, it does seem so. Now next thing I want to do is to make a loft like this. Loft. Something like this. And this loft function, it's not included in a Rhino3d IO because this is a bit more richer modeling function, which is hidden under the Rhino license. But if you have a Rhino work in progress version installed, then and running a server on it, running WIP on a server like this, and in my case in local server, then you can access to this rich function through a server. So let's do that. Okay, now before doing that, let's check the RhinoCommon API to see how to create a loft using Rhino Compute Rhino. Since Compute Rhino for C# is pretty much based on this Rhino Common API, C# API, so you can just use this as a reference, use this Rhino Common API document as a reference. So let's do that. Let's just search with the word loft, and I do see some method, and I think this one goes suit well. bread.create from loft, and construct one or more breps by lofting through sets of curves. And I think, yeah, this is the one I need to use. Now the function is called create from loft, and it's on the brep class, and it returns a list array of brep, and you need to have a curve starting point, which could be unset, which is optional, and also a type of loft and whether it'll be closed or not. Okay. So I guess I need to have a list of curves in order to use this create from loft. So let's make a list for curves by making a curves called new list curve, or Rhino geometry curve. Okay, and add this curve into this curves list like this. And here comes where I need to use a compute service, compute Rhino service. Now in order to use a compute function for breps, I have to write like this. So starting from vrep and compute. So if it's mesh, it's mesh compute. If it's curve compute. This time it's vrep compute, and the one I needed to use is create from Loft, and there you go. You have this. Now enter curves as an input, and what was the second input? So point 3D start, point 3D end, and it is optional, so I'm just gonna set it to Rhino geometry point 3D unset, Rhino geometry point 3D unset. And next thing is a loft type, so Rhino geometry loft type to normal. And do you want this to be closed? No, I want to make this open. Okay, now I have those breps called from the server. Now let's see if I have really got the result by adding to this model again. Now let's cancel this, comment this out, and for each vrep var vrep in vreps model add model objects add vrep to check. Okay, let's close the Rhino window again and run. And let's see if I got the model. Going back here, and I don't seem to have the result here. Okay, let's check it again. Okay, maybe I haven't saved this. Okay, I have just saved this file and click to run the scene. And okay, I seem to have some error. Okay, unauthorized access exceptional token must be set, and I forgot to set the token here, which I made it public variable. So let's go back to this login page for the compute Rhino service. Copy this token and paste it here. Okay. For this material, I'm also gonna set this material that I made inside the materials folder to here. Okay, save this and play again. And now I don't see any errors. Let's go back to the file to see if I got the model baked onto the geometry. And yes, it succeeded. It successfully called a loft function, which is only available in compute.rhino3d, and successfully made a geometry like this. Now this is pretty much the basics in using compute.rhino3d in C#, but what I want to do is to use it inside Unity, show it inside Unity, and possibly change the geometry procedurally in real time using something like sliders. So let's do that. Okay, the thing you have to remember using Unity is that Unity only accepts meshes in order to visualize the geometry. So what you need to do is to convert this vrep geometry into a meshes first. And vrep is a Nurbs geometry, so it is not compatible at mesh and initially, so you need to have some kind of, you need to use some kind of function in order to convert it into meshes. And this function is also available in compute.rhino3d service, but not in Rhino3d IO. So I also need to call through the server for this function in order to convert it into meshes. So let's do that. Okay, so the one, let's check the name of the function that combines mesh to, I mean vrep to mesh. I guess I need to, let's first go to the Rhino geometry namespace and go to a mesh class. Okay, and see if there's a function which converts from vrep. So let's search for vrep, and here you go, create from vrep. I think I can use this. Construct a mesh from a vrep. Yes, exactly what I wanted to use. So so I have this vrep. What I can do is to, well, first of all, as you can see on the Rhino file, it is open on the first, it is open on the side, on the edges. So I want to close this first, cap this first. So let me cap this geometry first to make a solid. The cap function is included on the Rhino3d MIO, and it is called cap planar holes. And I have to set up some tolerance, so I'm gonna set it to something like this, and then having this geometry set, let's convert this into mesh. So what was the name? Create from vrep, and you get the array of meshes as a return. So var meshes, mesh compute create from vrep, okay, and convert the capped vrep. Okay, now since I'm looping through all the vreps that I created from the Loft, so let's create a mesh list, which is a list of meshes. And add all the meshes I created using add range, like this. Okay, now I have the list of Rhino's mesh geometry inside a mesh list. Now what I need to do next is to convert this Rhino's mesh into a Unity's mesh, and since this is both are different classes, it has different properties in order to create a mesh. So you have to kind of translate what it says on Rhino and translate it into a Unity language. So let's do that. And for each, or a mesh in mesh list. Now, although in order to make a procedural meshes, it's basically the same in any kinds of softwares. What you need to have, it's basically a vertices and faces and sometimes normals and UVs. This time I'm just gonna get vertices. I'm just gonna translate vertices, faces, and normals in order to visualize it in Unity. If you want to use textures, maybe you want to also bring up the UVs as well, but you'll know how to do it while I translate the vertices and faces. Now first let's create a new mesh object for Unity. Okay, well, the name of the class is same in Unity and Rhino, so it's a bit confusing, but without having rhino.geometry, it's a Unity's mesh, so don't be confused. And create a vertices empty list for vertices using vector3, and also a empty list for triangles, which is used to construct the face in Unity, which is a list of integers, and also a normals, which is a list of vector 3. Right, now let's loop through all the vertices inside Rhino's geometry mesh, which is this one. So for each bar mesh vertex in mesh dot. Now if I look through the properties, I should see a property called vertices. So let's iterate through this list, and what I get is the geometry called 0.3f. So it's pretty straightforward. What I need to do is to make a vertex converted into vector 3. So create like this, and mesh vertex x mesh vertex. Now this came since you have to flip the y and z. For the second input for the vector 3, it will be z from the Rhino, and the third one will be y. This is the place you need to be careful when you convert from Rhino to Unity. And add this vertex into the vertices list. Okay, let's go to the faces next. For each bar mesh face in mesh, there should be a list called faces, this one. Now if you check this geometry's type, it's called rhino.geometry.meshFace, which is not pretty much familiar. Let's see what it has. So if I type dot, I have A, B, C, D, and is quad or is triangle. So it could be either triangle or quad, and if it's triangle, it will be A or B or C. It has A, B, and C, which is a integer index for the vertices. If it's quad, it will have D as well. So let's make a condition. If mesh face is triangle, then add the integer mesh face C triangles, add mesh face B, add mesh face. Now the reason why I'm starting from C and go to A is because I already tried this, and if I started from A, the mesh is kind of flipped, so I'm making from the backward. and else if mesh face is quad, if it has 4 points, 4 vertices from each mesh, then well, the Unity doesn't have quad meshes, I believe, so it always have to be converted into triangles, I think. So I need to have 2 triangles in order to visualize the quad. So I have to copy this twice to have 6 indices, and starting from CBA, and you also need to have include DCA. Okay, something like this. Okay, and last of all, let's also bring up the normal. So for each var normal mesh normal in mesh normals. Let's check the type, and this is vector3, so it's pretty straightforward. So normals, add new vector3 mesh normal x, mesh normal z, again mesh normal y. Okay, now I have this arrays or list prepared. What I need to do now is to mesh object vertices to be set as vertices. Now I think I need to convert it into array, and mesh object triangles, feed it with this array, and mesh object normals, feed it as well. Okay, should do. And I do have a mesh object, but in order to visualize this I need to have a mesh filter and a game object. So create a game object and attach a component called mesh filter, and to a mesh property gonna put in this mesh object. And also in order to render this, I'm gonna have to have a mesh renderer. So I add the mesh renderer, and for the material I'm gonna set the material, which I have in the public property, public variable. Alright, now I seem to be able to make a function in order to convert the vrep to a mesh. Here, let's check to see if anything shows up in Unity. Okay, let's play this, and here you go. I do have something shown here. Let's check it out, and cool. So this is the mesh result, the converted mesh from the vrep, which is made using Rhino3d MIO plus compute.rhino3d. Now I made it as a static object. Let's make it possible to procedurally control this geometry using sliders. Okay, now I'm gonna have to use the update functions, and I'm gonna have to check whether the slider value has been changed or not, since I don't want to always run this generate geometry on every frame. It will be too heavy. So I'm only gonna run this when the slider value has been changed. So I'm gonna have to make a check-in function, whether the slider has been changed or not. Okay, so bool, first make a bool update geo function variable starting from false, and if previous height is not equal to height, which means the value has been changed, then update geo to be true, and prev height will be the same as the height. Okay, let's copy this and paste it 3 times more. For this one, prev angle is not equal to angle, then prev angle is angle. This one, prev radius, pipe radius is not equal to pipe radius. Set the pipe radius to the prev pipe radius. Oops. Okay, last prev segments. If prev segment is not equal to the segments, which means if the segments has been updated, then update geo's being turned to true. Okay, now if update geo is true, then call this generate geo. Now, one thing you need to be careful is that whenever you call this generate geo functions, it creates new meshes, so you also need to delete the meshes that is being produced previously. So let's also make another function called private void delete meshes, and write some functions in order to delete all the meshes in the scene. So first of all, get all the meshes by using find objects of type. I'm gonna search for the mesh filter, and for each object and objects, first let's destroy the object mesh and destroy object itself, game object, and rest of all, just to make sure, unload unused assets to clear up the memory. Okay, and call this before the generate geo here. Right, and let's comment this out, which is on the start. Okay, now let's see. Let's see if I get any errors. No errors. And yeah, I'm already be able to change the height procedurally. And pipe radius, angle, and segments. Yeah, that's pretty much it. It's surprisingly pretty fast to calculate this, even though it's through a local server. Yeah, it's pretty fun. I mean, being able to create a procedural model using inside Unity by calling a REST API is pretty, promising for a lot of stuff, I think. You can use it for I don't know, standalone application which connects to the internet to create this kind of complex geometry or you could also use this in iPad or iPhone as well, on a tablet, to create a geometry inside those small spaces, mobile spaces. And since it could be built for a standalone like Windows, you can also use it in VR spaces. So while you're in VR space, you can also create this kind of procedural geometry, which is also sounds promising. Now I hope you find it useful. I'm gonna post this file to a GitHub as well, so that you can just copy and paste to use this directly. I don't mind people using this for any kind of purposes. Just keep in mind that using a compute.rhino service, it's still in work in progress version from McNeil, and in order to use a local version of compute.rhino3d, you have to have a Rhino 6 license in order to install the Rhino work in progress to use this service. Other than that, it's pretty promising. Yeah. Okay. Thank you.